All right, here are the explanations for your study guide. I'm going to do the first page as a video, and then I'll do the back page as a video. So the first one is explain the difference between a prime number and a composite number. Give a couple examples of each. So I'll just write P for prime. Prime numbers have only two factors or divisors. So they only have two factors, so it's one in itself. So an example of that could be 7. The ways to make 7 or numbers that can divide 7 equally are 1 and 7. 13, 1 and 13. So prime numbers have only two factors. Composite numbers, I'll just write C, have more than two factors or divisors. Remember, if you know the factors of a number, those are also the divisors. So a number such as 6, 1 times 6, 2 times 3. These are the factors and divisors of 6. How about 12? 1 times 12, 2 times 6, 3 times 4. So composites versus primes. The next question are multiples. What are multiples? Just like the word suggests, we're going to be multiplying, and the multiples of 12, we just multiply the 12 by a whole number, and generally we just go in order. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 48, and 60. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 40. And multiples will go on forever, right? They'll go on forever. Next question is factor. Oh, I missed one. So then we learned about the LCM, or the least common multiple. So once you list out multiples of two or more numbers, you look for the least, the smallest, right? The smallest common multiple for 12 and 8. So if you look up here, you see that they share 24. 24 is the first multiple that they share, so it's the least common. We couldn't do greatest common, right? Because multiples go on forever. So 24 is your least common multiple. Factors of a number, that's like saying, what numbers can I multiply to make, in this case, 9? So 1 and 9, and also 3. So if you think of 9 as factor pairs, 1 times 9, 3 times 3. So the factors are 1, I should have written them in order from smallest to largest, 1, 3, 9. So 33, we go over here, 1 times 33. All numbers, remember, have a factor of 1. So 1 times 33, and then 3 times 11. So it's 1, 3, 11, and 33. And then once we know the factors of two or more numbers, we can find the greatest common factor. So we look at our factors and we find the one that they share, that's the largest, and in this case it's 3. So the greatest common factor of 9 and 33 is 3. And we can use the greatest common factor to simplify or reduce fractions. So if we know that the greatest common factor of 9 and 33 is 3, we can reduce by dividing both the numerator and the denominator by the greatest common factor. 9 divided by 3 is 3. 33 divided by 3 is 11. Number 4. The school nurse is creating some first aid kits to give teachers for their classrooms. There's 100 bandages. I'm going to underline that. There's 100 bandages and there's 25 cough drops. If the nurse wants to make as many kits as she can, as many, and that's bolded, and I'm going to underline it again, how many kits can she make so that each kit is identical, so that uses up all the supplies? So no supplies can be left over. So what are we doing? We're really dividing up 100 bandages and 25 cough drops. So we're dividing up 100 bandages and 25 cough drops into, let's just say a kit looked like a little bag, how many bags or how many kits would we need to have in order to divide up all of these equally? So if you're dividing something up, here's our hint, list out the factors. So if I list out the factors of 100, I can say 1, 2, 4, 5, 10, 20, 25, 50, and 100. 100. Those are the factors and divisors of 100. 100 is a composite number. 25 is 1, 5, and 25. Well, what's the greatest common factor? The greatest common factor is 25. So that tells us how many kits. So we would have 25 kits delivered to the teachers. How many bandages? Remember, these were bandages and these were cough drops. How many bandages would be in each of the 25? Well, 25 times what gives me 100? 25 times 4. So there'd be 4 bandages. And then 25 cough drops divided up into 25 kits. You'd have 1 cough drop per kit. So list out the factors. The greatest common factor tells us the number of kits. And then from there, we can figure out how many, in this case, bandages and cough drops could go in each. A faster and more simple way, I'm just going to do it quick, was the upside down cake method. We put in our 100, we put in our 25 cough drops, and we say, hey, what's a prime number we can pull out that they both have in common? Well, they're both divisible by 5. So we could say 100 divided by 5 is 20. 25 divided by 5 is 5. Another layer of the cake. What can we pull out? A number that's prime, that's common to both. We could pull out a 5. 20 divided by 5 is 4. 5 divided by 5 is 1. And then greatest common factor starts with a G. And I taught you in class, if you make a G, an imaginary G, you multiply those two together, you still get 25 kits. And what's cool about the cake method, it takes 4 bandages and 1 cough drop. So you use the way that works for you. Most people will do the list. Number 5, Miguel gets every 3rd day off. I'm going to underline that. He gets every 3rd day off from his job, and Elle gets every 6th day off. Every 6th day. If they want to schedule a time to get together and play basketball, on what number day would they both be available? So Miguel gets every 3rd day off, and Ellie gets every 6th day. So we're not dividing anything out like we did up here. We're trying to figure out how many days would go by before they can play basketball together. So in this one, we're doing multiples. So the multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 4 is 12. I'll stop there. The multiples of 6. 6 times 1 is 6. 6 times 2 is 12. I'm going to stop there because we already have a match. So on the 6th day, they would both have off and they could play basketball. So the 6 is the least common multiple. The least common multiple. And you can also use the upside down cake method, or I showed you prime factorization. Okay, moving along. This is an exponent, right? A number with an exponent. This is an expression. So 4 to the 3rd power. Remember, this is the base number. And the exponent tells us how many copies of the base to multiply. So it's saying multiply 3 copies of the base. So in expanded form, that's 4 times 4 times 4. So don't add these together, multiply them. 4 times 4 is 16. 16 times 4 is 64. So 4 to the 3rd power is equal to 64. 3 to the 4th power. 3 to the 4th power. 3 is the base number. the exponent's saying multiply 4 copies of the base. So 3 times 3 times 3 times 3. So that's expanded form. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81. So those are the solutions for the first page of your study guide. Hopefully that helps you if you had questions on any of them. I'll do the back side on a different video so it's not so long.